shape is a trapezoid. So if you look at your formula sheet, and you go under where it says trapezoid, you'll find area is equal to 1/2 the sum of the two bases times the height. We're going to substitute our known values in. So the area they told us was 250. So we have 250 equals 1/2. Base 1, it does not matter which base you're going to let be the first base, okay, because we're just adding. Times the height, which we don't know. That's what we're going to solve for. We want to take care of order of operations, so please excuse my dear Aunt Sally. So we're going to do parentheses first to kind of clean this up. So 250, 1/2, 20 plus 30 is 50. One half times 50, 25. Divide both sides by 25 to get h alone. So this would make our height 10 inches. So we found this little piece here. Inches. Notice that I didn't say inches squared because 10 does not represent the area. It represents a dimension. You only use units squared when it's the area equals. So that's been a misconception today before you guys came in. So, what kind of questions may I answer? All right. Raise your hand if you and your partners need a little bit more time. Well, how many more minutes? Maybe 1 or 2? Okay, 1 or 2 minutes. Okay, 1 more minute. Formula. I think our minute's just about it. All right, raise your hand. Give us the formula for it. Yes, ma'am.
16 times x over 2.
Okay, well, so first of all, which formula did you use off the formula sheet? I want to make sure everybody knows which formula to use. Okay, now tell me.
Okay, 16 times x over 2 equals 248.
All right, so check. This is how you substituted your numbers in. Okay, she used x instead of h. It doesn't matter. Okay, as long as you remember what you're solving for. Okay, no, you're fine. So 1/2 of 16 is 8. We'd have 8x, 248, 31. So our height is 31 inches. Oh, I'm sorry, not our height, our base. Pardon me, our base. See, I forgot what we were looking for. Our base. 31 inches. So we found this piece here. Okay? All right. We have one other type of problem that we're going to do today, and that is finding the area of a shaded region. So we're going to do one example of that. These are circles. I do realize that they look a little like ovals. Make yours look more circular than mine. Okay. Because of this 20.
Wait, isn't that for the floor?
Mm-hmm.
So but then don't you subtract the area?
Mm-hmm.
But how far down the area?
So the area of the whole circle, and you said the radius was 10. Okay. Now one of the things, guys, so that we make sure our number is pretty accurate, is we don't want to do any rounding until the very, very end. Because if you take a number and you round it and then you do something else with it and round that, you're going to continually be off and you're going to have a bigger margin of error. Okay? So we're going to wait and do rounding at the very end. So 10 squared times pi, we're going to call that 100 pi. Okay, but we're not rounding yet. We're not rounding yet. Sure you are. You already rounded pi, 3.14.
Oh my God.
Okay? So we start out with that whole circle, and then we're going to cut out these two smaller ones. So we need to find the area of the two smaller circles. So there's two of them. So I'm going to go ahead and do both at the same time. So 2 times pi. What's the radius of one of those small ones? So we said this whole thing was 10. So each one would be 5. Okay, good. Let's see how we came up with that. I took 20 and divided it by 4, essentially, because there's 4 radius that make up the full circle. All right. Again, I'm not going to multiply by pi yet. I'm going to do that at the very, very end. So 5 squared is 25 times 2 is 50 pi. So remember we started out with that full circle and I threw away these two smaller circles. So we need to do a subtraction problem. 100 minus 50. So 50 pi. Now we can multiply it out. 50 times pi. $157. We'll round to the nearest tenths place. So 1 decimal place. So 1. 50 times pi.